Hello everyone, welcome to DSP NIT AP. This is Durga Pavan Kumar, EC 3rd year BTech. In this video, we will discuss about one of the realizations of digital filters, digital form to structure. Realization of a filter is nothing but converting a given transfer function h of z into a suitable filter structure that is generally depicted using block or flow diagram, which shows the computational procedure for implementing digital filter. Basically, realization of digital filters can be classified into 4 types. First one, direct form 1 realization. Second one, direct form 2 realization. Third one, cascade realization. Fourth one, parallel realization. Given equation is a transfer function h of z. In the transfer function h of z, numerator consists of coefficient of zeros and the denominator consists of coefficient of poles. In the transfer function, we are having z power minus 1 and z power minus 2, z power minus m. In this, z power minus n represents the delay. For example, z power minus 1 denotes 1 step delay, z power minus 2 denotes 2 step delay. And when we come to direct form 1 is also known as zero pole realization, whereas direct form 2 is known as pole zero realization. Direct form 2 structure is an alternative to direct form 1 structure. It is more advantageous to use direct form 2 structure because it uses less number of delay elements than the direct form 1 structure. When we consider direct form 1 structure and direct form 2 structure, we can see, unlike direct form 1 structure where summing blocks are closer and delay blocks are away, here in direct form 2 structure, delay blocks are closer. In other words, we can combine them by reducing the delay, which is the main aim of filter design. That is, a single delay line can be shared between all poles and all zeros. To understand the concept of direct form 2 structure, we'll consider one example. As direct form 2 structure is known as pole zero realization, we will consider first pole of the transfer function, which is nothing but the denominator. We will represent denominator of the transfer function as h1 of z, and if we cross multiply and apply the inverse Fourier transform, we will get v of n in terms of x of n and delayed v of n. And if we write the flow chart or flow graph for the h1 of z, we'll get this diagram with the input x of n and output v of n. And now coming to the zeros, we'll consider zeros nothing but the numerator of transfer function as h2 of z. After cross multiplication and doing inverse Fourier transform, we'll get y of n in terms of v of n and delayed v of n. If we write the flow chart for the h2 of z, we'll get this diagram. After combining h1 of z and h2 of z, we'll get the required direct form 2 structure with the input x of n and output y of n. At the input side we are having poles and at the output side we are having zeros. In the conclusion, the advantages of direct form 2 over the direct form 1 is the number of delay elements used in direct form 2 is less than that of direct form 1. And the limitations of direct form 2 are it lacks hardware flexibility, there are chances of instability due to quantization noise. Thank you.